Hello everyone, my project is about forecasting the daily Bitcoin price. The dataset, we use the dataset from Federal Reserve Bank of St. Louis. The daily prices in USD of Bitcoin trade on Coinbase platform. All data is as of 5 p.m. of Pacific Standard Time. Is not seasonally adjusted. Data was stored in both CSV and Excel format, and it is free to download at any time. So that's why we choose this dataset. The use case, we want to predict the price of Bitcoin for the next 7 days. We use both traditional methods and deep learning method. For traditional method, we use exponential smoothing and ARIMA. Both of them are very popular in time series analysis. And deep learning method, we use stateful LSTM method, and we also compare performance of all models. So the solution for exponential smoothing, we use whole winter models, and for ARIMA we use 111 model, which is the best model from auto ARIMA function. For deep learning method, we use stateful LSTM with time step set at 7 and 3 LSTM layers. The time step is set at 7 because the nature of the data is also the weekly data, daily of weekly data, 7 days. So for the optimizer, we use Atom optimizer, and the loss function is mean absolute errors, because this mean absolute errors is more resistant to outliers, which is the high and low fluctuations of daily price. We train the data 120 times at batch size 32. So here are the graph of the result. We see the blue line is the actual price from the testing set. The red line is the forecast of LSTM models, and the green line is the ARIMA model, and the orange line is the whole winter exponential smoothing models. And from the data collected on the 22nd of August, the stateful LSTM model predict the data on the 23rd of August is about between 10,400 and 10,500. It's about $10,450 per Bitcoin. Now we talk about the architectural choices. The data source, as we mentioned before, we chose to download from the website of Federal Reserve Bank of St. Louis because it's free, and everything was saved in both CSV and Excel format. For data integration and repository, at this stage we use Watson IBM Studio to combine the data, process the data, and to keep the daily data. For discovery and exploration, we use Python 3.6 with pandas, NumPy, matplot, and request package. Actionable insights, we use Watson IBM Studio with Python 3.6, including pyramid and start model package for auto ARIMA and exponential smoothing. For application and data products, we use Excel to save the data and to save the forecast data, and we use Watson IBM Studio to print out PDF report, which you from Jupyter Notebook. About data quality, there are some missing data from the time series. Prices and dates are in string format, so we have to deal with that before doing the analysis. For data pre-processing, we need to delete past missing data from the time series. We need to convert prices and dates from string to numeric format and to date format, and we need to set dates as index of the time series. For feature engineering, we make training set with 7 time steps for training the stateful LSTM method, and about 10% of the data was saved for testing the model on the models, and we use on latest daily price to test on models. We also scale the data using min-max scaler for LSTM method. Model performance indicator. We use mean absolute error as the loss function because it's more resistant to high fluctuation of daily prices. We test on the model with testing sets. Model algorithms. We use Horn-Winter model with no seasonality for exponential smoothing models. We use auto-arima with stepwise searching and differencing order d equals 1 to search the best ARIMA model. For stateful LSTM models, we use 7 time step and train the model 120 times. Loss function, again, we use mean absolute error. So that's on the basic technical information about the models. Thank you for your participation.